Today, we're going to be looking at how to actually use the equations to solve kinematics problems. First off, we're going to go recap the 4 equations and the 5 variables, and then we'll go through the process that I recommend. You don't absolutely have to follow this process. However, it helps you to set up the problem and gives you a way to approach every single problem, not only in kinematics, but a way to solve every single problem that we're going to be doing here in physics and in other topics as well. Okay, first, let me recap the 5 kinematic variables. The first variable we have is displacement, okay? Some indication of position. How far have you moved in the x direction or the y direction? The next 2 variables are the velocity, okay? Your starting velocity and your final velocity. Because when we have acceleration, that velocity can change. And don't forget, it can also change direction because velocity is a vector. So it changes not only in magnitude, but it can change in direction. In the beginning, we're just going to start off with a one-dimensional, so the direction is only going to change either forward or backwards. Okay, but as we move into slightly more complicated problems, we will be working in 2 dimensions. The 4th variable is acceleration, denoted by the letter A, and the last variable is time, denoted by the letter T, or sometimes delta T, because it's really the change in time from time 0 or whatever to another time. Okay, these are our 4 equations of motion, okay? The first one is basically says that the final velocity is based on your initial velocity plus acceleration times time. Okay, the next one says that your displacement is going to be initial velocity times time plus 1/2 at squared. The third one is your final velocity squared is equal to your initial velocity squared plus 2 times the acceleration times the displacement. And the last one is that your displacement is equal to your average velocity, represented by v final plus v initial, divided by 2 times time. These are equations in the sense that we can substitute for the left side, numbers for the left side or the right side. Okay, we're not always solving for whatever's on the left side. Okay. These 4 equations of motion use our 5 kinematic variables. Okay, they're all missing, however, one variable. If I look backwards, okay, that first equation, Vf is equal to Vi plus At, doesn't have displacement in it. And that missing variable is actually going to be key. So that's why I go through this process, because I find a lot of times people struggle in terms of determining which equation do I use, especially in the beginning. As we get more confident or more practice, that ability to identify the equation gets easier. Okay. And this is the 3 variable requirement. Before you can use any of these equations, okay, to solve, you need to have values for any 3 variables, okay? Because if I have any of those 3, I can go back and use one of those 4 equations to solve for the remaining 2 variables, okay? And it's that missing variable that's going to be important. So here's our 4 equations. There is a 5th equation, but we don't really use that one. Okay, largely because it's the missing kinematic variable is very rarely Vi, so I don't really use that one, and I don't require you to memorize it. Okay, but the 4 equations are there on the left. Okay, and they're all missing a kinematic variable. Okay, it's that kinematic variable. Okay, when I write down my variables, okay, given the problem, I'll have 3 of them will have numbers. A 4th one I'm trying to solve, it's that missing 5th one, okay? The missing 5th one tells me what equation do I need to use, okay? So let's look at a problem, okay? And how do I solve it, okay? The vast majority of problems in physics can be solved by starting with the same first 2 steps, okay? 3 if you count step 0. Step 0 is basically draw a picture. This is a step that you can skip if you can visualize it easily. However, as the problems get more and more complicated, it becomes more and more important that you actually draw a picture. Okay, in the problems that we're going to be working on, okay, it probably makes sense to label an origin on the picture and also label which direction is positive. Okay, is the rightward direction positive? Is upwards positive? because that's going to determine the sign of your variables. Okay, most of your variables are vectors, and the direction corresponds with the sign. Okay. The first step, though, really is to write down your known variables. Okay, in this case, my 5 variables: displacement, initial velocity, final velocity, acceleration, and time. Okay, so here's an example problem. Okay, I have an airplane that accelerates from rest down a runway at 2.80 meters per second squared for 42.5 seconds. Determine the distance traveled before takeoff. Okay, reasonable. And I see 2 numbers here, so let's. I'm going to skip the picture part. Okay, it's a fairly simple problem. Actually, let's not skip the picture part. Okay, let's draw the plane. Here's, whoops. Here's my plane, and it starts from here, and it accelerates at 2.80, so I'm going to call this my positive direction, and this is at t is equal to 42.5 seconds. It takes off. Okay, determine the distance traveled before takeoff. Okay, so there's my picture. Step 1 is to write down my 5 kinematic variables. Okay, the problem is repeated in the lower right hand corner, so you don't have to memorize everything. Okay, but just write down in the same order every time. That's fine. Okay, the more you can put it into something you don't really have to think about and do the same thing every single time, the easier it gets. Okay, so here's my 5 kinematic variables. Okay, I have 2 numbers listed in the problem. Okay, let's put those numbers in. Okay, so I have the 2.80 and the 42.5. Okay, so my acceleration, which is in meters per second squared, gets assigned to acceleration. My time, which is in seconds, okay, gets assigned to that one. Okay, there's only 2 numbers in the problem, and you need to find that third one. Okay, that third one is the fact that I start from rest. Okay, so therefore my initial velocity must be 0 because rest means I'm not moving. Okay, my recommendation after that is to put a question mark. What am I trying to solve for? It reminds you that that's what you're trying to solve for. The X tells you which one don't you need, because that's going to tell you what equation you're going to use. In this case, I don't need a VF. Okay, so continuing on, do I have 3 values? Okay, in this case, I do have 3. If you can't find that third number, okay, you're going to need to go back and reread the problem. Look at your picture. Figure out what's going on physics-wise, because there must be a third number buried in the text somewhere. Okay, but once you have that and the variable with the x, you can plug that into an equation. Okay, and it's not this equation, but because it's wrong. Because VF is the one I don't need, okay, then it would be this equation. Okay, so fortunately, the VI being 0 means that my first part of this expression goes to 0, so I can ignore it. And I would then just have distance is equal to 1/2, my acceleration of 2.80, my time of 42.5. Don't forget to square that. Okay, and then I would plug that into my calculator. Okay, so using a calculator, I would solve and get the answer to that question. Okay, thank you.